So we finished up doing basically everything with exponentials and logarithmics. We've done all the operations, we've solved equations. So let's go ahead and see what these things look like if we graph them. So we're just going to graph a few exponential and logarithmics, just some basic ones, and then in the next lesson we'll look at what happens if we move them, if we do something called transformations of these graphs. So let's just look at the first one. Say we have something like y equals 2 to the x. And what we're going to try to do is we're going to try to get a common thing that these look like, a common shape, a common curve. Kind of like with parabolas, we knew that all parabolas look like a U. So we're going to try to do the same thing for exponentials, see if we can find a common curve that all of these look like. So we'll start with y equals 2 to the x, and we're just going to go ahead and set up a little bit of a chart, get some ideas of some of the points, and let's just start with the 0. If I put 0 in for x, 2 to the 0 is 1, so I have 1 point already. 0, 1. If I put in 1, 2 to the 1 is 2. If I put in 2, 2 squared is 4. So I can start to get the behavior. So x is 1, y is 2, x is 2, y is 4. If I went further, if I put in 3, I would get 8, so it would be up here. If I put in 4, I'd get 16. So it's just going to continue rising. It's going to start rising pretty fast. So I now know the behavior of that graph as it goes to the right. Okay, so let's put in some stuff to the left, some negatives. If I put in negative 1, I'm going to get 2 to negative 1, which negative exponents we know flip it over the fraction bar. So 1/2. Okay, so that would be somewhere right here. If I put in negative 2, get 2 to negative 2, which is 1/4. So even closer to my x-axis. If I put in negative 3, I'd get 1/8. If I put in negative 4, I'd get 1/16. Really, it's just going to keep getting closer and closer to that x-axis, but it's never going to hit it. It's never actually going to hit 0. We call that something. We call that an asymptote. So this, because it's getting close to this horizontal line, this horizontal x-axis, we're going to call it a horizontal asymptote. Let me write it out real quick. And this horizontal asymptote is going to be at 0. We learned before with axis of symmetry that whenever it's a vertical line, it's x equals. So when it's a horizontal line, it's the opposite. It's y equals. So this is going to be at y equals 0. Okay, so let's look at the other exponentials we have here and see what they look like. So if we have 3 to the x, I'm not going to plot points this time. You've already seen the chart. So we can just kind of do it from our head. So let's put in 0. 3 to 0 will be, well, 1. How about 18? 18 to 0 will be 1. So both of these are going to have that same exact point as our 2 to the x. They're all going to have that 0, 1 point. Okay, let's see what happens when I start going higher. If I put in 1, I would get 3. If I put in 2, I would get 9. If I put in 3, I'd get 27. So it's still shooting up. So it's shooting up a little higher, faster I guess, but still shooting up. Let's look at 18 to the x. If I put in 18 to the 1, I'd have 18. It'd already be up there. 18 to the 2 would be whatever 18 squared is. So this would shoot up ridiculously fast. Okay, so let's see what happens if I put in negative numbers. If I put in 3 to negative 1, I'll get 1/3. If I put in 3 to negative 2, I'll get 1/9. So again, getting closer to the x-axis without hitting it. Same thing with the 18. 18 to negative 1 will be 1/18. 18 to negative 2 would be 1/18 squared. So getting closer to the x-axis without hitting it. So they again are going to have this x, or this horizontal asymptote on the x-axis. So they'll have the same one. I'm going to abbreviate it now just to HA. Y equals 0 and HA, y equals 0. So what we can deduce from this is that all exponential equations are going to have this shape. You see how they all have the same shape? It's a shape that, well, they all go through that point 0, 1. And to the right, they shoot up. To the left, they go toward the x-axis and flatten out. Some are going to shoot up quicker. 18 to the x shot up a lot quicker. 2 to the x didn't. But they're all going to have this general shape. Okay, if this was my axis. So any exponential should look semi like this. Not any, most exponentials. Any exponential where the base is greater than 1 should look like that. Real quick, see if we can find domain and range of these. So if I look at 2 to the x, the domain, I want to check again. Does it look like it's going all the way to the negative? So all the way out here. Yeah, it should. So negative infinity. Does it look like it's going all the way to the positives? Yeah, slowly, but it's going all the way to positive. There's nothing stopping it. So negative infinity to infinity. How about my range? Checking to see if it goes all the way down and all the way up. So does it look like it's going all the way down? And it doesn't. This thing never gets below that x-axis, so it never gets below 0. Never even hits 0. So 0 with a parentheses to show it never hits it. Does it look like it's going all the way up? Yeah, it looks like that graph is going all the way up. So 0 to infinity. Okay, my range of the next two would be the same. So now let's look at a log equation. Say I have y equals log base 2 of x. This is a little hard to figure out. Subbing numbers in for x are going to be a little strange because I'm not as comfortable with logs. So what I can do is go ahead and change this to an exponential. Remember to change it to an exponential? We take the base, we swing it over, and we pop up that on the other side to be the exponent. So I would get 2 to the y equals x, and that drops your log. So I now have it being an exponential, and now I can sub stuff in. Well, hopefully you notice that this is the exact same exponential as up here, except that my y and my x are changed. So really, my values for y and x are going to be changed. I can check to make sure, but in this case I'm subbing numbers into my y. So I'm subbing in a 0 into my y, a 1 into my y, a 2 into my y, -1 and -2. I should get the exact same values I got up here, just again, changed. So my x would be 1, 2 to the 1 is 2, 4, 1/2, and 1/4. So let's go ahead and try to graph this. So I'll have the point 1, 0. Okay, I'll have the point 2, 1. Make sure you graph it x, y. 4, 2. And then I'd have the point 1/2 and -1. And 1/4 and -2. So my graph should go something like this. This time it still has an asymptote, but it's going to be a vertical asymptote. And since it's vertical, it's going to be x equals, and this asymptote is going to run straight down the y-axis this time. So it's still going to be x equals, in this case, 0. Can check the domain and range. My domain, does it look like it's going to hit everything on the left and everything on the right? Well, no, it doesn't look like it's going to hit everything on the left. It stops at 0. It doesn't even hit 0, so 0 to infinity. My range, does it look like it's going to hit everything down and hit everything up? Yeah, so this one would be -infinity to infinity. Okay, so I can do the same thing with y equals log of x. We don't see a base, you know the base is 10. So I can take that 10, swing it over, and pop up that y, get 10 to the y equals x. So again, I could do the same exact chart. I would have that one point in common. 10 to the 0 is 1, so I'd have that point 1, 0. This time though, when I subbed in a 1 for y, my x would be 10, so I'd have a point over here, 10, 1. So again, it does change the rate that it rises. Okay, and let's see, if I subbed in -1, I'd get 1/10, -2, 1 over 100, so it's flattening all the way down. I guess becoming a cliff vertically and all the way down. I'm not really sure how to say that. So again, it's got the asymptote. So it has the vertical asymptote at x equals 0. My domain, still going to be 0 to infinity. And my range, going to be -infinity to infinity. So these are two graphs that you should be able to graph, pretty okay. Especially exponential. Exponentials are easier to see just because we're more used to seeing the x in the problem. So hopefully you can draw them out well, without having to plug in that many points. Hopefully you can just kind of draw it out. Okay, well, we'll look at transformations of graphs next.